LabVolt ET10-E Power Transmission Smart Grid Technologies Training Systems allows teaching of three-phase AC power circuits and transformer banks, AC transmission lines, high-voltage DC transmission systems, static VAR compensators, and static synchronous compensators.
The students will first learn three-phase AC power circuits using a fully variable three-phase power supply, along with three-phase resistive loads, capacitive loads, and inductive loads. This will allow them to see three-phase circuits, three-phase power measurement, and phase sequence. When the versatile 4-quadrant dynamometer power supply is used as a power supply, it can act as a DC voltage source of up to 150 volts positive or negative, and can also be used as a current source positive or negative up to almost 5 amps. Please note that this power supply is reversible, meaning that it can both supply power as well as sink power. It can also be used as a variable voltage 50 Hz source or as a 60 Hz source.
To get measurements that are easy to understand and to connect, we use a data acquisition and control interface which has 4 voltage inputs as well as 4 current inputs.
The data acquisition unit helps the students understand the important concepts of phase shift, reactive power, and power factor in AC circuits by using powerful instruments such as phase angle meters, active, reactive, and apparent power meter, and a power factor meter. It can also use a phasor analyzer, which allows you to see what happens when you change the nature of the loads. A powerful oscilloscope that can display up to 8 traces of voltages, currents, or instantaneous power also really helps the students understand these concepts. Instead of using precious lab time to copy data, the students can use the automated data table to create graphics that will be easy to understand and save them time to further understand the theory needed for these labs.
Three-phase transformer configurations such as delta to delta, Y to Y, Y to delta, and delta to Y will then be studied.
The students will then see AC transmission lines learning voltage regulation characteristics, voltage compensation, power transmission capacity, voltage compensation in long AC transmission lines, and control of active and reactive power flow. The data acquisition and control interface will also be used to control power thyristors, allowing the study of high-voltage DC transmission systems. The students will see topics such as voltage regulation and displacement power factor in thyristor three-phase bridges, basic operation of high-voltage DC transmission systems, DC current regulation and power flow control in high-voltage DC transmission systems, commutation failure at the inverter end, and harmonic reduction using thyristor 12-pulse converters. The students will then go to static VAR compensators, seeing the main components of a static VAR compensator, voltage compensation of AC transmission lines using SVCs, and power factor correction using SVCs, for example on arc furnaces.
The last topic of this system is static synchronous compensators or STATCOM. Students will learn voltage compensation using a STATCOM and power factor correction using the same technology.
The modularity of the system makes it very easy to add or remove topics to fit your program better. For example, you could easily add motor drives, power electronics, home energy production, basic DC and AC circuits, wind turbine generators, hydroelectricity generators, and many other topics. The full color books include both theory and practical exercises that will help the students understand all of the necessary topics.
In summary, LabVolt Power Transmission Smart Grid Technologies Training System is flexible and has the power to teach all the necessary topics for an advanced world.